Today we're going to talk about section 6.3, which are parabolas. And we talked about parabolas in section 2.3, but we talked about them as functions. So we really only talked about half the set of parabolas. A parabola is actually the group or locus of points in a plane that are equidistant from a fixed point, F, called the focus, and a fixed line, the directrix, in a plane. So if we have a parabola, this blue thing here is a parabola, and we have our focus, the green line here, and our directrix. And if you have any point on this parabola, say here, then this distance from here to the focus, straight line, and from here to the directrix is the same always. The distance from the focus to the parabola at the shortest point, we actually have a special letter for, we call that P, and the shortest point is this vertex here. So from here, the focus, to the vertex is this distance P, and it's the same as from the vertex to the directrix, just like every other point on the parabola. Every point on the parabola, it's the same distance from the focus point to that point, and from that point to the directrix. That's the definition of a parabola. Now, we talked about, we had a formula in section 2.3 where we used this one. We said y equals a times x minus h squared plus k. And we're going to use a similar formula now, but we're going to be a little bit more specific with this a to try to figure out what it is. So what it really is has to do with this p. The a is actually 1 over 4p. And that'll tell you something about the parabola, its distance from the focus to the vertex. So all the little formulas that we need are on your formula page. They're listed, most of the time we list our formulas like this so we don't have to have all the fractions and things in it. But if you multiply this out, distribute that, and then solve for y, you get y equals 1 over 4p times x minus h squared plus k, which is just what we used here. We just, like I said, are being more specific about what a is, what it means in relation to the graph. Because remember, every equation you deal with has a graph. It has a picture that shows you all the points that will satisfy that equation. So, we know from this our focus point. Our focus point is h comma k plus p, and our directrix is a horizontal line, so it's y equals k minus p, because our vertex here is h comma k. We know that from chapter 2. So if we have our k value and we add our p to it, we're going to get the focus, and if we subtract our p, we're going to get the directrix. Just remember, the directrix is a line, so it usually needs to be written as a line equation. We also learned about this a here, if it was positive, which in this case, same thing is going to happen if p is positive, then it's going to open up, and if p is negative, then it's going to open down. So this is for parabolas that open up or down, like this. But this is only one set of parabolas. This is the set we talked about in chapter 2. But there's another set of parabolas that aren't functions. You can also have a parabola that's sideways. It also has a focus and a directrix, because that's the definition of a parabola. It also has a vertex point, and you can learn all kinds of things about how it does from its equation. Now in this case, we have just a little bit of a switch around. Here's our general equation. And in this case, just like before when they were opening up and down, we solved for y to look at it. We're going to solve for x. Now, these solving for x and y equations are not on your formula sheet, so you may want to add them to your formula sheet. So, if you look at it like this, then you have your equation. If you have x equals and y is squared, then you know it's right and left. If you have y equals and x is squared, then it's up and down. So just like before, our vertex is h comma k. And now, instead though, our focus is moving right and left. So that means that we have add the p to our h instead of the k. And for our directrix, we have a vertical line this time. So we have x equals h minus p. If our p is positive, just like it told us we were up before, this time it's going to tell us that we're opening to the right, like this one does. And if our p is negative, then it opens to the left. Okay, so those are the generic equations for parabolas. Now remember, this one is not a function. It does not pass that vertical line test, so it's not a function, but it is a conic. And like we talked about before, those conics aren't functions anyway. So let's try one. If I want to graph this parabola, well, first of all, I look at it and I say, okay, it is a parabola because there's only one squared term. Remember the circles and the ellipses, and later we'll talk about hyperbolas, they have both x and y squared. In this case, we've only got one of them squared, so we know it's a parabola. So what we need to do is see which is the not squared term and solve for it. Well, y is our not squared term, so what we need to do is solve for that. And then we use all our rules we learned in chapter 2. So we have x squared minus 10x plus 19 equals negative 2y. Now, why did I leave this big space here? Well, if you remember when we were doing parabolas, one thing that we learned was that we had to complete the square. All conics are based on getting them into these generic forms that we can work with, these working forms, and you've got to be able to complete the square to do that. So we're going to complete the square here. If you recall, we divide this one by 2, so we get 5, and square it, so we have plus 25. Now remember, with parabolas, we still want everything on the same side. So we look, we check there's nothing out here, so we just added 25, so that means we need to subtract 25 off here. So we end up with x minus 5 squared minus 6 equals negative 2y. Now, you might ask about this negative 2. You can divide through by before, but then you end up with fractions in front. You have to factor those out, and it makes it a little bit more complicated. This way, we just get our fraction at the end. So we divide the whole thing through by negative 2. And we end up with negative 1/2, because remember, dividing by negative 2 is the same thing as multiplying by negative 1/2, times x minus 5 squared plus 3 equals y. So here's our working form of the equation. Well, what does that tell us? That tells us our vertex is at 5, 3, because this is our h. Remember, x minus h plus k. So our vertex is at 5, 3. Now we can also solve for our p so that we can find our focus and our directrix here and know whether it opens down or up. So we look at this and we know that that is 1 over 4p. So we set it equal to negative 1/2, cross multiply and solve, and you get p is equal to negative 1/2 because we've got 2 equals negative 4p. So once we have our p, we see it's negative, so that means it opens down. We know it's down and not left because the x is the squared thing. When we solve for y and have a squared x, we're going up or down. So we're opening down. Then we also know that our focus, let's get a new color here. Our focus is going to be the point 5, 3, and then we have to add our p. So it's 5, comma, 2.5. And then our directrix is, remember that's the line, so it's y equals k minus p. So that gives us y equals 3.5. So now we can graph everything. So we've got, let's see, we're going to 1, 2, 3, 4, 5, 3 for our vertex point. And then our directrix is at 3.5. So there's our directrix. And then our focus point is at 5, 2.5. So there's our focus. Now, if you recall, we said when we graphed parabolas before that they're even functions, and the easiest way is to get a point on either side so that we can figure out where they go. The other thing we said was finding their zeros helped us a lot, because that way we could figure out where it crosses the axis. So remember, that's when y equals 0. So 0 equals -1/2 times x minus 5 squared plus 3. So we subtract our 3 over here and then multiply times -2, and we get 6 equals x minus 5 squared. So we've got to take the square root of both sides. And remember, that means we have plus or minus the square root of 6 equals x minus 5. So x is 5 plus or minus the square root of 6. That's the roots, the zeros of this parabola. Now, what is that in decimals? Because it's kind of hard to see this with a graph. Well, that's approximately 2.551 and 7.449. So we go and we know we're going to be here. 1, 2, 3, 4, 5, 6, 7, 8. And we're going to be here. So we've got this one and this one. And again, graph paper would be much better. So we found our vertex. Once we got it in working form, we can find all these things: the vertex, the directrix, the focus, and then we found our zeros just so we knew where it went. If it's not going to cross the axis, of course, you just find a point on either side so that you know how far it opens. Because this number out front, the 1 over 4p, is a fraction, that's why it opens up so much fatter than normal. So, parabolas. They are conics, so they do have an eccentricity, which, remember, that's how it differs from a circle. But the eccentricity of all parabolas is 1, so there's nothing to calculate there. We'll talk some more about this in class. Make sure you've read this section and reviewed section 2.3 so we can make sure we are solid on parabolas.